Hello, everyone, and thank you for joining this webinar, Control the Chaos, the Rise of Network Observability, in collaboration between Capacity Media and Kentik. My name is Jack Haddon. I'm a senior reporter at Capacity Media, and I'll be hosting this webinar. And I'd like to introduce Greg Villan, Senior Director for Product and Design at Kentik. Hello, Greg.
Hello, everyone. Thanks for having me.
And Steve Meuse, who's a Solutions Architect, Service Provider, also from Kentik. Hi, Steve.
Hello.
And during the webinar, Greg and Steve will walk attendees through a tour of how network observability puts network operators in the driver's seat to face the challenges of an ever-changing economy and focus their engineering and operational efforts on what matters, which is cost, performance, and reliability. So during the webinar, you're going to learn what is network observability, some tools and methods for simplifying complex hybrid network data, and the infrastructure decision framework, cost, performance, and resilience. We'll then have time for a 15-minute Q&A at the end, so please send questions throughout the webinar. I believe that Greg and Steve will also be pausing to answer some of your questions while we go as well. And there's also going to be some polls that we're going to be running during this webinar as well. So if you want to contribute to the poll, which we recommend, there's a vote tab just underneath at the bottom of your screen down here. So you can use that. And in the unlikely event that you experience any technical difficulties during the webinar, just refreshing your window should kind of sort that out. So yeah, that's all from me. I'm now hand over to Greg and Steve.
Good morning, everyone. Let's start with a little round of intros here. My name is Greg. I've been one of the important things, I guess, when I introduce myself is to mention that I've spent half of my career as a practitioner. Built networks almost everywhere in the world, different shapes and sizes. But what's really important is that being a practitioner, and I forgot to mention that I own the service provider portfolio here at Kentik. And what's important here is that as a practitioner, I get a chance. I've gotten a chance in the more than 7 years that I've been at Kentik from the beginning almost, is basically to build a product that I needed in Y2K when I was a network engineer architect, with the help of our very valuable service provider customers here. And I'll pass the mic to Steve, who will assist me today in this presentation. Steve?
Yeah. Hello, everybody. I'm Steve Meuse. I work on the revenue team here, working specifically with our service provider customers. I've spent most of my career working on internet-style networks from back in the early 90s from file providers, and then working for some of the U.S. country's largest backbone providers. So I think if you look at Greg's experience and my experience, the product team, the sales team here at Kentik really has a very rich, including our support teams, have a really rich service provider heritage. So we look forward to working with service providers, customers, and specifically to help them solve some critical business problems.
All right. Just a little word about Kentik, the company that Steve and I both work for. We're not so much of a startup anymore. I think people tend to call us a scale-up. We're around more than 400 customers all around the world. As you can see, our customers are pretty happy with us. And we ingest a gargantuous amount of records of telemetry per week in the trillions. And so you see a few of the names out there. They're kind of spread across the map of different networks, service providers, which are Steve and I's specialty, but also a lot of large enterprises and content providers and such. I'll go on to the next slide. And before we start with the first poll, what are we here to talk about today, right? So we're here to discuss network observability. Now, as any term that gets coined by Gartner, there's a lot to unpack in the term. It's a little bit of a catch-all term. Kentik being one of the pioneering companies that helped kind of define the genre in the last decade. Let's try and look at what we're going to do today is try and look at the elements, the foundational elements that we have always put on the forefront as being the pillars of network observability. For those who don't get time for that, infrastructure observability is just the modern way of building and operating infrastructure on the internet. And so we're going to start with the first poll, which I'm going to fire just now, and I'll give you a minute to answer it. The vote tab below the video should allow you to express your vote. I'll give it a minute here, and then after that, we'll get started. So the poll question is, how many tools is your organization using for network operations management, monitoring, and troubleshooting? And during our presentation, Steve is going to jump in every now and then to add some color and details around my voice. And I am going to end the poll in a few seconds if you'd like to give it your last votes. All right. Here we go. Poll is ended. So before we get into that, just gonna take a look at the past decade, right? And see things that have changed. So on the technology side, the left side of the slide here, what we can definitely agree on is that complexity of networks and infrastructure has kind of drastically increased, and that's just by product of Moore's law, pretty much. Whether it's SDN, overlays, underlays, networks have become more complex. The other thing is that internet has become critical to every single enterprise, and I'll explain that in the right side panel. We've seen a lot of hybridization, if that's even a word, of networks, right? A lot of network providers now are both cloud and on-prem, so that's something that we have to take into consideration when we talk about network observability. Appliance models have really gone the way of the past. They're really not a thing anymore, or less and less. Infrastructure tools have proliferated. People talk about swivel fatigue. There's been obviously a massive rise of external threat. We see that on an ongoing basis every day. And AI and ML are starting to be the big elephant in the room that you can't touch anymore. And so all that to say that basically your Y2K monitoring stack is just not cutting it anymore. And multiply that by a somewhat difficult context over the past 10 years, right? If anyone's been alive for the past 10 years, we've all been hit by a major pandemic, and working from home has now become the new standard. And so this has made internet critical for every single enterprise, honestly. And because of the pandemic, because of the ongoing and past geopolitical conflicts, we've seen quite a sudden economical downturn, though we're getting out of it. What we've experienced firsthand from that is some pretty severe hardware and connectivity supply chains really going bad, and like energy prices going up. I remember in 2022, power costs in France did an impressive times 12 over 1 year, which forces everyone to realign the way they build and operate their networks without any prior warning. And so what I mean by that is that there really has been a strong need for a much more agile stack to cope and adapt to a fast-changing context in the past years. And so if we want to go through a little bit of archaeology here, if you go like prior Y2K, really the Stone Age where you only had SNMP and lugs, then the next step in a stack evolution was the rise of NMS, network management systems, where you had reactive monitoring in the sense that something happened that caused an issue with the network. You reacted to it by creating an alert so that next time it happens, you knew about it before it happened. So it was mostly reactive. The next evolution of it was NPMD, Network Performance Management Diagnostics. And it came with a few technologies such as like the rise of NetFlow, packet capture, deep packet inspection, and some amount of analytics and anomaly detection. And so in that era, we were more looking at, we added the ability to explore the unknowns, not what has happened before, but what may happen, what may have been, and what the causes of how things happen. So querying for forensics, for instance. And here we are today in the age of infrastructure observability, and I'll use infrastructure and network interchangeably here. But that we can see the rays of cloud being covered in the same stack, but not only cloud, host, container. We're adding synthetics, we're adding DNS, we're adding routing, and really the whole deal here is being able to directly ask questions to your infrastructure. Versus trying to piece together a ton of signals from a ton of silos in your tools stack. And this is a slide that's pretty dear to me because it's really ingrained in my mind as my experience of having been a network engineer or operations network engineer for ages, is the idea of silos and bottlenecks, which makes it most of the time really hard to manage infrastructure efficiently. So the first one being data, telemetry data being locked in silos, whether these silos are teams, engineering, ops, but also finance and execs, teams that are not directly technical teams, but that still account in the decision-making process. Also the tools, I mentioned swivel fatigue. Now there's NMS, there's flow analytics, there's synthetics, there's DPI, logs, routing, application performance monitoring, and thirdly, some external sources of truth, whether these are your contracts, your peering DB data sets, RPKI, the routing registries and such. And there's really no bridge between these silos. And one of the things that comes out of that is that one of the ways to efficiently run and manage network is to run efficient and very frequent cadences and reviews. And the way a lot of teams are set up really doesn't allow, because of the workload that it creates for these automated and frequent reviews, right? So it's always a case of, well, we need to get an engineer to extract all of that data, and then we need to heavily massage it in spreadsheets and then like format it into slides so that they can be consumed by other teams in a company that are not properly engineering teams for proper decision making. And so that we've seen that this doesn't work when we want to take decisions rapidly and efficiently with an analytical mindset. And when it comes to that, ops are always on a critical path of obtaining all of that infrastructure analytics and handing it over and then passing it on to someone who massages it and passing it on to someone who formats it. And so really what it results in, at least that I've noticed in the past, is that we reduce the frequency of these reviews and operational reviews, and they become quarterly, and it's a massive amount of work every time they happen. And when this doesn't happen frequently enough, what results is that decisions are made on hunches and not really analytics, whether these are technical, sales, or finance decisions. And it all results in really inefficient tracking when it comes to capacity, cost, or whatever. And this is where network observability has really a great set of answers. One of the key things is democratizing access to the infrastructure data. The other one is simplifying and summarizing and contextualizing that data to offer it to others in a company. Therefore, helping the company to make like really efficient decisions, but in self-serve mode, where you don't need an engineer to get you that data and explain it to you, and really build reusable routines and dashboards and reporting that are like available at all times by the entire company. And so, if there's any competitor in the room, please pay attention. We'd love you to join us in that movement that we're on the forefront of, which is, here are the things that we think make great network observability. And so let's go beyond the market pitch and kind of like try and summarize in a few bullet points what network observability is. First off, it's all your infrastructure telemetry in one single platform, data store, place, UI. That's one thing. Both friendly with on-premise and cloud. That's the second one, and directly inherited from what I mentioned early on. The fact that it needs to speak internet natively, and I'll explain later why this is not always the case for anything DIY. The other item is really democratized guided access to enriched telemetry. Don't stick to the basics. Add your stuff on top of it. The other one is really guided and open. And the last one is all of the above within the SaaS platform. And I'm going to give examples as we go through this presentation of what I mean by all of these items here. And so I'm going to take these one by one and kind of like give you a little heads up on what I think these are. And so all your telemetry in one place, all your infrastructure in one place is really enriched telemetry with really high cardinality, multi-dimensionality. So whether it's flow, routing, SNMP, or streaming telemetry for the more modern, performance and synthetic testing, DNS and radius feed, eBPF, all the way up to the container and kube, and any arbitrary time series, but also external data sets, routing registries data, peering DB data, route views from RIP dumps all over the world, scans of the internet, and so on. And then business data, such as contracts, application definitions, all the way down to exchange rates, and however you want to color your telemetry with your own stuff, with your own attributes that make it meaningful to you. And all of these metrics need to be unified under a single query engine and a single query interface. That's a very important thing. We talked about silos. That's the way to break these silos. And all of that, obviously, supported by a unified and scalable backend. And that's the pretty hard part, if I may say, when you'll be considering DIY. And then on-premise and cloud, so all the vendors and all the MIBs and all the standards, that's a lot of surface here, but that's mandatory nowadays given how great networks are. And all environments, whether this is edge, backbone, data center, WAN, campus, SDN, you name it, it needs to cover all of these bases. I said all clouds, obviously, because now there's a pretty good split between these public cloud providers, Azure, AWS, GCP, Oracle, Kubernetes, all of that, again, within a single data store. That's again, a very important criteria. Speaking internet natively, because a database is a database, it doesn't particularly understand internet. And when I say understand internet, it understands inter and intra-domain routing, the notion of ASNs, RPKI for security of routing, but also GeoIP. One more difficult thing is how it needs to understand the notion of a CDN or an OTT or whatever digital supply chain means and is. So that's a big one, and I'll double click on that later on. And natively understand dynamics such as peering, transit, IXs, and interconnection. That's also a big deal because this doesn't come natively with telemetry in general. Then I've insisted on that quite a bit when I said democratized guided access to enriched telemetry. It's the whole being able to provide dashboarding for everyone in the company. Also ability to include easy exploration modes where you look for the unknown unknowns, as we call them in the company. Includes guided workflows that are centered around very specific tasks that your teams are doing on a daily basis to kind of like compact the time that it takes to do these routine operations. The idea that it needs to contextualize enriched telemetry so that it makes it digestible and understandable not only by the engineers. One of the key things here is letting the users ask questions as a way of supporting and networks and building them. And we'll get a little bit into that later because of ML and AI and what it offers. And really simplifying the context for non-engineering and operations team, because that's where the buck usually stops. The information rarely goes over the fence into the next silos when it really needs to be for efficient decision making on infrastructure.
Hey, Greg, let me interrupt.
Go ahead, Steve.
You know, the experience that I've come from most of the service provider organizations that I've worked for on the democratization is that there's always been a very large telemetry collection platform of some sort. but there has always been a very small handful of people or one group that is the only group that really has access to it or can get data back out of it efficiently. So one of the things that we've really focused here at Kentik is making sure that no matter what your job function is, whether you're a frontline ops person or whether you're in accounting and you need to review traffic data to compare to a bill, or you're a data scientist, no matter what your job function is, that the UI can serve your role and allow you to, obtain that business objective, right? So the accounting people can look at the bills, and reconcile them against the data, or a data scientist can go and build very complex queries to get the needle in the haystack, or the frontline ops person can simply click something to get some frontline information. That's sort of a key element here. That's very important from the operations perspective.
Definitely. Thank you, Steve. And it all goes back to the silos and bottlenecks that I was mentioning before, which are kind of one of the huge untold sunken costs of building and operating networks. Then we want this network observability to be guided and open. So when I say open, it's portable and enriched data, whether this is API first, PDFs and CSVs exports. The fact that analysis is out of that platform should be able to be shared with non-users. That seems like something that's not really by design, but like something you really eventually need on a daily basis. You need to have also data available to downstream systems, because you've got your other systems that allow you to build and run the network, whether this be network automation, whether this be ticketing or chat ops or notification integrations. And really, genuinely, it needs to be brownfield friendly with the rest of the data lakes and other observability pipelines in the company. So that's really openness and compatibility with brownfield is something that's hugely important.
Everybody should be thinking API first.
Yes. And that's how we've built product, because we're a somewhat recent company, although somewhat recent is a term that works less and less when I talk about my employer, because we've been there a while now. And lastly, I will never emphasize enough the benefits of a SaaS platform. First off, because of the constant need. I mentioned the context around networks is evolving really fast. So there's a deep need for high feature velocity. Also, when we talk about these amounts of data and these gigantic data sets, the ability to not have to operate it and basically bypass the entering and ops overhead to deploy and operate at such a big data platform at scale is critical. The bigger your network, the more voluminous your telemetry, and really like the idea of on-demand and instant scalability. When your infrastructure upscales and downscales, you don't want to have to engineer for it, really. And so these are like benefits. And I'll go further down in the benefits later in that presentation. And so we're going to get to some very specific examples that kind of like are outlined by the previous slides that I showed you. But before that, we're probably going to go for a second poll if I find where that poll is at, and I'll launch it. Again, you can answer it with the vote tab that's below here. And I'll give you about a minute to answer it before we get further. Okay, let's go then. And so before I get into the examples, I tend to use very simplistic frameworks to make decision-making much easier to myself. And so with these, I've come to the conclusion that there's a very, very simple infrastructure evaluation framework, which is basically any infrastructure project will either be approved faster, will either be successful, better successful, as long as an emphasis on provably and analytically helps improve one of these three dimensions, and the more dimension it validates, the better, which is helps with cost, helps with performance, and helps with robustness, resilience, security. This is a very if you always go back to this framework, decision making tends to be much easier because the simpler set of attributes here. And so in all of the examples that I'm going to give, I'm going to try and refer back to that. And so let's start with connectivity cost. I mentioned cost, performance, and resilience. Really, one of the things that I've noticed as I manage connectivity for a various amount of networks is every time you look at an invoice, a transit invoice, for instance, it doesn't match what your provider is giving you. And so you need, and especially when you're in the middle of a somewhat sharp economical downturn, you want to track connectivity costs much more efficiently. And so that requires data that's in a bunch of silos, right? You get your router configs with your interface descriptions that tell you what the interfaces do. You get your SNMP for interface telemetry. You get your exchange rates if you're unlucky enough to have a network that spans all over the world. And you have your provider contracts that sit in PDFs somewhere else in finance. And you need to munch that and massage that. And it's a nearly impossible exercise. Let's be honest, it's spreadsheet hell, but there's hope. So the challenges here is that complexity of computing costs efficiently and recurringly is the number of contracts and how different every single bandwidth contract is. Obviously, that data is spread across multiple silos within that on the left side diagram here, and we don't really have a unit to compare all connectivity providers. And obviously, the obvious one is dollars per or whatever currency per megabits per second to be able to compare. To see if you get the right provider in the right space at the right cost, right? And the other thing is that these spreadsheet models, they usually fail to capture a few things such as sunken costs, whether these are cross-connects, backhauls, cost, and so on, but also fail to detect underusage of commits, which is something you should always try and reclaim, specifically when you're trying to streamline cost and everything. And one of the results is like basically nobody does month-over-month tracking of connectivity cost, nor does any form of invoice reconciliation. And the other thing is that it's not, as far as I've witnessed it, the exercise is rarely multidimensional. Like you don't look at cost per site, per megabits per site, or per provider, or per connectivity type, whether it's transit, peering, exchange, all of that. And so for that, network observability has a really cool answer, which is automating programmatically the link between contract interfaces, exchange rates in a very simple admin interface, having a role engine to color your interface based on SNMP data as to the role that they have, and that'll allow you to attach different costs to them, having a data engine that crunches all of that every day, computing the P95th and the history by contract and connectivity type and so on, and have auto-generated reports for easy tracking. And that will allow you to prepare your negotiations whenever your bandwidth contract term, transit contract term expires. You want to come to that meeting with your bandwidth salesperson, well educated on how does it compare with other providers that you already have? Is your price good? Are you underusing it? All of that information should be readily available at hand. And really, the ultimate goal here and is to be able to instantly determine the cost of any slice of traffic in your network. That's the key. Towards any ASN, whatever the interfaces it goes through. And so this is what it could look like. And I'll keep sprinkling Kentik screenshots here and there because we think we did it properly. So looking at megabits per second cost or overall cost for every provider that you have, but being able to precisely model all of these contracts with the tiers, the commits, and the additional costs and the additional cost per interface to translate the cross connects and blend all of that into a cost per megabit per second is something that's really, we noticed that with our customers who started heavily adopting it during the first signs of the economic downturn, trying to rationalize their spend. But this also applies when you're someone who sells connectivity, right? The money you make on customers is highly dependent on where traffic goes goes to and comes from, right? And so I've got a little diagram here where I'm looking at a customer named customer number 1 on the left side of it, where you can see the traffic from that customer entering your router, and it goes throughout your network, exits in multiple places with a different cost every time for every different slice that it takes. Sometimes you get hot potato routed to another customer on the same router, which is a lot of heavily beneficial for you. Sometimes it crosses your network and goes into a paid peering, which is really not a high ROI in that case. And so whenever you're selling bandwidth and it's contract renewal time, you want to know easily and really fast, and if possible by a salesperson and not needing an engineer, what your ROI is on that customer. And that can't happen if you can't easily determine the cost basis for every of your customers in real time. And as I said, as the diagram explains, like the traffic profile of all your customers is different, completely different from one customer to another. And sales need to be able to know that without needing an engineer sitting next to them when they're talking to a customer. And so the answer in that Network Observability is offering here is a kind of a rules engine to automatically, and this rules engine I already mentioned in the previous one, which knows what interface does what in a rules engine system kind of. And the other bit of magic here is being able to know where traffic exit when it enters the network and marking that, enriching that data. And it's kind of magic that we're kind of saving here, because I think we get a patent on that. And so let's look at that same customer here. And so that customer is connected in Seattle, which is the light blue part. And so you'll see that there's some hot potato from Seattle to Seattle. What I call ultimate exit site is where the traffic from that customer is exiting. That goes to another customer. So that is highly beneficial, right? It's revenue generating. Whereas traffic that goes from that customer, customer 1, goes transatlantic and then goes into peering, is not as beneficial as the other slice. So you want to look at the proportions of this and see what's in it for you, ROI was for the entire customer over the entire source and destination networks that it's going to or coming from. And I have not seen a lot of transit providers being able to offer that information on short notice without needing an engineer. That's the other point. And so I'll keep going with peering and interconnection, because it's something that I've done quite a bit in my life. One of the things I've noticed, and you have too probably, is a lot of it is based on arcane knowledge, peering decisions. It's all based on Rolodex and poorly documented decision-making process. The data is heavily siloed once again. You've got your flow data somewhere, you got your peering DB data to look at footprint, you get your routing registries, your route views. And when it comes to deploying the network beyond its current footprint, I've seen way too many guesstimates and very little analytical decision-making. And so these are simple questions with very tedious, at least more than they should be, answers. Like, for instance, what's my common footprint with this ASN or network, right? How much traffic can I peer off at this internet exchange? Which internet exchange in Europe is better for me given my traffic? Like, these are questions you should be able to answer quickly and very simply, right? And so how do we answer that? We need to be able to dynamically compute and display the overlap of my ASN and any other's network without needing to jump from one silo to another. And so that goes through enriching telemetry data with peering DB data, peering DB being the kind of the directory of the who's who of yellow pages for those old enough of peering here. And we need a multi-criteria traffic and querying engine that's able to leverage all of this, whether it's connectivity type based on interface classification, as I mentioned before, based on geography, based on peering policies, and based on footprint as defined in peering DB. And so ideally, what you want to be able to do here is tell me where it would make the best financial sense to deploy my network next. That's the golden question, right? And so here's an example. Being able to look at any network, see all the internet exchanges that they're on, highlighting the ones that you have in common, and then from there looking at your flow data to see what your traffic profile to or from this network is, and being able to see all the other members at this exchange that they're at. But that doesn't stop here. That's I'll call that the peering DB integration part of your network observability. But for instance, being able to say, okay, what IX should I deploy to in Virginia? I want something on the East Coast. So you will look at potential traffic towards Lynx Nova, north of Virginia, Equinix Ashburn, and Digital Realty Ashburn, and look at traffic that would go to the ASNs that are members of this internet exchange. So that's basically a simulation that you can run at any time. And so that's a really cool example here with a good query engine that supports dimensions linked to peering DB, for instance. And another one is, wait, can I optimize my sessions at AMP6? Like, do I have sessions on transit, traffic on transit that I could shift on AMP6? Well, I can ask my engine that and get a question and immediately raise the peering request associated with that without making any guesswork or needing to extract data from 3 silos and then merging it all together. The other thing I mentioned, speaking internet natively, and I want to spend a little bit of time on CDNs and OTTs because these are terms that do not exist natively in any form of telemetry. And as you can see, and this is like specifically complex to parse diagram, and don't worry, you can download the presentation after. Figuring out when you're an enable ISP, for instance, where traffic comes from and who are the networks behind it is much more complex with CDNs, which are basically overlays on a bunch of other networks. So you've got content that's directly from the content providers, content that comes from caches in the CDN's network, content that comes from caches in your own network if you've embedded any of these. But there's no native way to look at that in telemetry data. So you need something that's able to color traffic with all of that. And so, again, CDN and OTTs, not native. All CDNs work completely differently, and their routing policies keep changing left and right, making things even harder for you to determine. And it's a highly multi-dimensional problem, right? Any OTT service can leverage multiple CDNs and transit providers at the same time and shift across time. And commercial CDNs, conversely, carry traffic for a large amount of content providers. And so it makes it pretty difficult to figure out what the path is for a certain CDN or OTT. And remember, when you're an eyeball ISP, your subscribers do not call your support line saying that you got an issue with Akamai. What they say is basically, my Netflix keeps rebuffering, or I can't download my last Fortnite season fast enough. And so you got to be able to troubleshoot that quickly, right? And the last thing is that cost and performance for any CDN or OTT completely varies for all ISPs, and within the ISPs for all the delivery methods for that same content provider. And so you need to be able to disambiguate that and figure that out. And so you need to be able to map the DNA of every CDN and in real time. And basically, what you need to do that is to be able to identify all IPs of all CDNs at all times in real time. Building a hostname-based dictionary so you can match DNS query responses with flow data and merge them together in a consistent view. And so, for instance, I'm looking at, like, it's a random example here, but that's just for one OTT. In that case, it's HBO Max. I can see that I got traffic coming in multiple sites through peering, IX, transit, from a large amount of providers, upstream providers, and source CDNs. And let me remind you, performance, quality, and cost is different for all of these slices, right? And so that is extremely important for you to know about. And for each one of these slices that uses different provider and a different set of interfaces, you've got a different capacity allocations on each of the interfaces elsewhere. But all of these still impact, in that case, HBO Max, right? I've got interfaces everywhere to different providers. In that case, we're highlighting an Akamai PNI. And all of them are in different capacity states. So that's a big important thing you need to be able to do. And so with all of that in mind, and I've got much more examples than we have time to go over, but I mentioned previously democratize guided access to energy telemetry, and I specifically skipped AI and ML and large language models. And so we've been playing with that for quite a bit now over at Kentik, and I wanted to share where we're at with that. And the way we look at it, there's steps for that. The first step is having a co-pilot where you can actually literally textually ask questions to your infrastructure. The other one is a methodology of troubleshooting that is iterative based on conversational troubleshooting, which is how engineers would do in a NOC or in a war room trying to figure out what an issue is. And then in the future, the next steps would be, at least on our map, is assisted root cause analysis, and then eventually assisted remediation, where we tell you exactly what went wrong and how. And so this is a good example of how the types of question you could ask. And so you get a co-pilot where you bypass UI and really lowers the bar to entry of who is able to support your infrastructure, from junior engineers to not even engineers in a company. And so really lowers the learning curve and completely blows away the silos here. And a few things come for free with that: localization, knowledge-based searching, config suggestions, all of that. We've seen applications that we never thought were that easy with AI and ML, in our case, with a Copilot. And the other one I mentioned was conversational troubleshooting. So you start and ask a question, the query engine goes and fetches the data for you, and then you iterate over that by asking questions. This is willingly looking like ChatGPT, because this is kind of the loop that we went for. And this looks a lot like also Python notebooks, if you think about it, where your study goes and you go further at every stage of it and kind of refine your analysis and with a user feedback chain.
Yeah, and Greg, from my experience, from an operations standpoint, that's been sort of the biggest change in operations UI that I've seen in a long time, because quite often you're given a problem statement of, like, there's a problem in Berlin, and so you have some vague starting point, and you need to ask some generic questions, and you keep on refining your query, but then you're like, oh, but 5 queries ago I asked for something, let me scroll back to that, and having all of the queries that you've asked for and to be able to jump back and forth has been eye-opening for the troubleshooting landscape, and it's the biggest change that I've seen in my 30 years of doing this.
And we're discovering new potential uses kind of like on a daily basis. So, and then lastly, I want to end by kind of trying to address the elephant in the room. Obviously, I work for Kentik. The question of build versus buy is kind of a trivial answer to me, but it might not be to you. So the things you want to consider, and this is on the left, are things I've heard like all day, every day. We have a few homegrown tools that are doing the job just right. We have this internal project to completely overhaul that stack, which is like the synonym for this is a white elephant project. It's never going to happen. Everything that goes wrong would be, it will be solved by that massive Phoenix project that we have here. And so a few things to consider, like PM account and Elk and Grafana setups. That's what I get most of the time on first intent. Well, these are all good and easy to demo, but then try and scale it. And we've been 10 years at doing that, so we get kind of a good idea. Now, things that people always forget is like how painful it is to ingest and enrich data at scale. And so it always seems easy when you park it, but when you actually build it, it becomes troublesome. The other thing is that open source projects out there rarely understand the internet, routing, subnetting, all of that. It may sound trivial, but it really is not. And the last question is really like, how much time do you want to spend on building tools for you to run your network and giving a great service to your end users versus kind of like focusing on your original purpose? So focusing on what you primarily do and let someone worry about the rest. And I've always got this like funny slide here, which is basically what we need at Kentik to build all of that, to give you an idea. And I'm not going to go through it, but really the intersection in the Venn diagram here is just a unicorn. And so whether you want to spend the time and budget to build all of that in a way that's not going to be reliable because you're going to try and learn how to do it as you go, that's when we're here to help. And if you've got any questions, like, we'd be more than happy to help you with that. And so any questions now? And I made it fit in less than an hour, so I'm pretty happy with myself.
I think after my 2-minute intro, that was bang on, Greg. So very good time management. Yeah, we have had a couple of questions come through, but just a reminder, if anyone's got any additional questions, you can pop them in the box just below the screen. So yeah, one question that we've had that I'll just read out now is, what are some best practices for integrating network observability with existing traditional network monitoring tools? So I don't know, Greg or Steve, do either one of you want to pick that one up?
I'm going to start with a cheeky, potentially bad answer.
That's all I can think.
Is you always think you can do that after when you build your system. And that's really the wrong way to go about it, because you will not. You need to think about it as a whole thing and build it that way. And amongst others, API first, open. It's in the way you build it and the hygiene in building it to make it open from the get-go. If you're trying to do that on the late, it's going to be nightmarish, at least in my experience as a practitioner. Steve, do you have anything you'd like to add?
I take a slightly different perspective in that we quite often work with companies who are transitioning between platforms, and it becomes a very eye-opening experience for them when they experience a SaaS platform for the first time for data of this scale. Because you can effectively be online and within 5 to 10 minutes and suddenly be monitoring, hundreds of routers on your network, it becomes an eye-opening experience for folks to say, oh my God, I thought this was going to be like a 3 or 4 year long transition off of my existing Flow platform, but the ease of use of the Kentik UI and the fact that it's SaaS, and I don't have to call up the data center to find space for 3 more racks and the power and the cooling. I can just call my account rep and get more licenses. It becomes an eye-opening experience for them.
Great. Anything that you would add to that, Greg?
None that I can immediately think of. I'll let you know if something like pops up. But really, like I mentioned the silos initially, and that's why the question is very relevant, is if you don't build to pierce through these silos early on, the more you wait, the harder it's going to be. So try and design your stack based on that.
Okay, wicked. Well, let's move on to the next question then, which is, what do you see as the biggest challenges facing network teams today in standing up robust end-to-end observability, and how have you seen customers overcome those challenges?
That's a fairly loaded question.
Yeah.
Really, one of the things that I've seen get in the way is thinking you can build it yourself, because it's always something that's easy to prototype. Like you take any open source project, Agvorado, or like some amount of Elk stack, and it works. It just works. You can prototype it. But when you get into the details of it, and I'm not even saying when you start thinking about integrating with the rest of your stack, when you think about producing these metrics at scale, you always underestimate how much effort this will take, I would say. And so that would be like the one of the first things. And really what we've seen is customers really getting in with a very tiny, narrow use case, and then seeing, oh, wait, rethinking the way they work based on a principle that I explained before, and gaining progressive efficiency, adopting more and more of that network observability kind of like set of principles. And so keeping these 6 principles in mind at all times and kind of like trying to solve for all of them in parallel is a thing that our customers have been fairly successful with, I could say.
Cool.
Yeah.
Anything else on that?
From my perspective, the build versus buy, the amount of manpower you end up needing to put into the solution ends up, costing twice as much as a commercial solution for that scale. Maybe on a very small scale, but that's not usually who we're dealing with. So the build versus buy gets expensive very quickly, and they end up coming back to us a year later after they've realized that.
Cool. Okay, so we've got one more question through, but there is still time, guys. If anyone's got any additional ones, please do pop them in the chat. So yeah, the last question that we have for now is, okay, this is a little bit of a long one. Open source and DIY methods are a popular approach to the network observability challenge. Can you discuss what you're all seeing in terms of open source versus commercially available offerings, and how service providers are evaluating which avenue is right for them?
Yeah,
Go ahead, Steve.
I was going to say, I've spent a lot of time on this front recently, and the things that we see is that there'll be the big corporate platform that was been purchased at the C layer, like, the CTO purchased the platform and everybody's forced to use it and nobody uses it. And then there's the network engineering team who secretly installs an open source platform of some sort, and it's under somebody's desk or not officially sanctioned by anyone. But that's the tool that everybody ends up actually using because it's actually so much more functional. But then they say, well, these tools aren't really very ops devy, so they build a Grafana, influx stack, TIG stack or something, and they start using these newer telemetry platforms that are all open source and scale okay. But the amount of time that they end up having to spend to customize the front ends and teach the front ends what a bit rate is and apply the network logic on top of these open source tools, that it's just a massive effort for them. So they end up falling back to somebody like Kentik. And we've seen the same pattern happen across dozens and dozens and dozens of customers, and it's really interesting phenomenon to watch.
And really, I don't mean to be bad-mouthing open source solutions because we're mostly built out of a lot of open source, and open source solutions do a great job at getting better at what's out of the box day by day. And so my advice is really get a feel of how you can complete these 6 pillars of network observability with open source. And I trust that you'll hit some scaling issues or some agility and feature issues. But get a taste of it initially with that. If it works, all the better. That really what matters for the benefits of your users is not what provider you select, but how efficient you're able to be with it. And so get a taste of it with that, because it's a good way to learn. And then go towards a more modern or buy model later on. And one doesn't prevent the other, I would say.
Makes a lot of sense. Okay, wicked. Well, I think that's all of the questions that we've had through. So I think we'll wrap things up there. Thanks everyone for joining. Don't forget to check out and download the attachments from Kentik, which include the ultimate guide to network observability and a case study from the guys with Edgio as well. Big thanks to Greg and Steve for joining us, providing some really great insights and answering those questions as well. Definitely don't hesitate to reach out to them if you want some more information on this topic. I'm sure I know they'd be very, very happy to speak with you. Thanks to everyone for joining and watching as well. I hope this has been useful for you. And don't forget to sign up to subscribe to Capacity for more webinars and more content just like this. Thanks very much, guys. Cheers for joining.
Bye-bye.
Thank you, everyone. And if you want to ever prolong the conversation offline, I'm easy enough to find, and my email is somewhat public on the internet. So, firstname@kentik.com, you can reach out to me to have discussions about network observability in general. We don't build product without listening to people, and so the more conversation we have, the better our products become. So please don't hesitate.
Wicked. I think we've attached the slides to this as well. So you guys can check
Brilliant.
those out as well if you need to. But wicked. Thanks so much for joining, guys, and hope everyone enjoys the rest of their day.
Pleasure. Have a good rest of your day, everyone.